Hello everyone, welcome to the video on Multimedia Information Networks. I, Dr. Komala, Associate Professor in the Department of ECE at SJBIT, would like to explain about the different multimedia information networks available for transmission of information on multimedia. The contents of this video are introduction to network, the local area network, Ethernet, the token ring concept, bridges, high-speed LANs, and the different protocols of LAN and multicast LAN interconnect technologies. So the different types of networks that that is available for transfer of information is the PSTN, ISDN, and PBX, which is private branch exchange. And in this, the main important type of network is the local area network. The local area network is used to interconnect the distributed communities of the end systems. The local area networks are always used to ensure that the transmission bandwidth is fairly shared between the sections that is attached under one particular node or multiple nodes. The local area network also will have an access for the number of different medium access controls methods that will be utilized, and the different MAC control methods are CSMA and CDMA along with token ring concept. So the different Ethernet networks are the IEEE 802.3 versions, which are very extensively used in technical and office environment. Coming for CSMA, that is uh, code division multiple access and collision detection. Here all the stations are attached directly to the same bus, or which is called as cable, and it is said to operate in multiple access mode, and this bus operates in broadcast mode, which means that every frame that is transmitted is received by all other base stations which is attached to the bus. Because of this broadcasting mode, this results in the contents of two frames, one being corrupted and is also said to be have a collision that has been occurred during the transmission of data. The CSMA or CD protocol, it is normally used under the method of carrier sense before transmission and sensing of the carrier information while transmission. The collision may occur between two or more stations when it is transmitting simultaneously. But the main difficulty is there may be some back off due to the random delay after collision during the data transfer. So to calculate what is the random delay that is available or the number of collisions that has been occurred, the transmission in the channel is sensed to be busy, which is calculated at a later stage. In IEEE 802.3, there is a collision window slot time which is created due to the round trip propagation delay along with the carrier sense time, and where the value may be in terms of 51.2 microseconds. The ending of collision is also an important part of the communication. So the occurred collisions is sensed by the physical layer, which is responsible for the transmission of data. So here a jam signal, which is called as collision enforcement signal, is initiated in all the stations which is involved in collision and detects the collision in the pattern of 32 bits. The collision backoff and the retransmission methods are normally utilized to calculate the number of collisions that are occurred during the propagation. So this is an illustration of the CSMA CDMA worst case collision detection. Here we can see that a data of packets or the segment of packets is getting transferred from the node A to node B, Here we can see that the transmission of the data or the transit of the data is being done in this frame without any delay. And here it is an illustration of the duplex transmission where the station A is also transmitting and the station B is also transmitting the data frames at one single point of time. Here the delay will be more where the node B transmits the frame from B to A. And the third instance where we can see that a collision has been occurred when the node B tried to transmit the data from B to A, and here once the collision is observed, then after the detection it is reconfigured or it is retransmitted by calculating the time delay in the diagram. So next, the second topic is up configuration principles, where here we can see the topology and the repeated schematic. Here we have a hub which is consist of the receiver and the transmitters along with a medium access control unit and a station which is attached to it. And here we can see that the different stations are available and the stations are able to transmit and they are also able to receive. So it forms a particular type of topology where the repeater scheme of topology is utilized. Coming to the IEEE 802.3 frame format. This is standard IEEE 802 frame format which is very much conditional to be followed. Here this is a frame format where we have a preamble which is of 7 bytes and we have a start of frame delimiter and there's a source or destination address which indicates where the particular data has to be transferred and from where it has been generated. So the destination address is where we are transmitting the data and the source address is where from where the transmission of the data has taken place. Next we have the type length and we also have the data which would be 46 bar 1500 and we also find a frame check sequence where this frame check sequence will help us to have a check on the frame and the sequence of packets that is transmitted over the network. So the sublayer operations of a CDMA and CSMA MAC layer operations. Here in this diagram we can see the transmitter and the receiver. At the transmitter end, the working of the sublayer operation is explained in terms of flow diagram. Here we can see that a frame is waiting to be transmitted and which is being arranged in the form of frame format for transmission. Once the carrier signal sensing will take place whenever the data frame is available, then the wait interframe gap time is calculated and the information transmission will be initiated which is transmitted. If there is any collision detection, then the complete information and the transmissions will be done once again. If there is no collision which has occurred, then the sequence is transmitted and the cycle is incremented for the next sequence to be transmitted. Finally, once again, the collision, the data which has been lost under collision, that will be retransmitted and then the complete execution of the data has been taken place from the transmitter. Next further, the data whichever is transmitted that is given to the receiver and the receiver will sense the incoming signal that is detected and there's a carrier sense signal which is set to on condition and after obtaining the bit synchronization the wait for SFD will be initiated so that the receiver frame will have a check on the frames that has been received. So each frame once it's received it has been transmitted, and if it is not transmitted, then there's a frame which will be discarded so that the retransmission should take place. So this is how we can observe that the data transmission will take place using the different methods and the layers of operations of physical data sets.